Hello there, I'm Thomas Hatsios, a German-American pilot flying the Boeing 787-900 tonight's flight. We're gonna be overflying Zurich, Switzerland, Germany. Then coming back to Zurich International Airport, runway 14 for an ILS localizer landing. So right now I'm in the cockpit of the pre-takeoff preparation of the quality wind Boeing 787-900 aircraft and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments and displays and the functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display. The displays are the airspace indicated, the airspace selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the altitude indicator with the pitch ladder degrees and the bank angle degrees, the artificial horizon, the ILS localizer, the instrument landing system receiver that receives the frequency transmitted from the runway's threshold antennas of the instrument landing system of its runway we use for takeoff and for landing. So we are in the Zurich International Airport, Lszh in Switzerland. I'm going to use the ILS localizer, one of the runway 14. So you will see it displayed in the primary flight display with the ILS localizer, horizontal localizer, and vertical glide slope that will help us line and guide the aircraft in the runway for landing. So I'm gonna show you also the ILS localizer course bus, the flight director course bus for manual guidance of the aircraft, and the autopilot course bus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode annunciator with the autopilot and the auto-throttle later and the communication modes. We have also the HSI with the integrated display of the flight plan and magnetic heading and track, and also in the navigation display we have the magnetic north pole and true north pole and magnetic variation depending on where we are in the world. We have the terrain map, the terrain and weather reflections from the weather radar. You can see the horizontal and vertical profile of the terrain around you. Also the flight, as you fly you can see the flight plan horizontally and vertically. You can see with the purple or magenta line. So I will show you right now in a couple of minutes how to create a flight plan using the flight management computer. It's going to be displayed in the navigation display, and the HSI with a purple or magenta line. You see the legs of each waypoint we have to follow from takeoff, climb, cruise, and approach and landing. You're going to see also the runway, the airport location, and the aircraft direction and location, and altitude, elevation above the ground level, all displayed in the navigation display and the primary flight display. So you will see them over here. You can see the navigation display here, the horizontal and vertical primary flight display. I still have not set up the flight management computer over here. So I will set through the flight management computer a flight plan or a flight path or route I will use. Also you can see the engines indications here. We have the thrust levers that display the engines indications. We have the autopilot flight director system panel over here. We're gonna set the airspeed heading, vertical rate of climb descent of the aircraft, or flight path angle, and the altitude select over here, target altitude, and also VOR localizer approach for auto run. We have also the FEs panel to set the barometric pressure in inches of mercury or hectopascals for the barometric altitude, minimum radio altitude, plan menu range, some displays here. In the navigation display you can change and see some systems of the aircraft like electrical, hydraulic, fuel system, pressurizer, and flight controls. So we have the range also of the terrain map. So you can see the terrain map displayed with red, green, and yellow indications over here for the terrain around you. So we have also the flight controls. I will show you right after how to use the side stick I'm using to control the yoke of the Boeing 787, to control the horizontal tail stabilizer, the elevator for climb descent, also make turns left and right, use the rudder pedals for the rudder. So this is I'm gonna show you later, after I will explain you a little bit about the flight management computer. So also in the navigation display you can see the display of other aircraft that fly around you. using the transponder, the ADSB and ADC transmit receiver that transmits our frequency to other aircraft and the air traffic control, and also receives from other aircraft and the air traffic control and displays in the navigation display the diamond shape of other aircraft. You can see the altitude difference from your aircraft, the distance they are located, the direction, whether they climb or descend with respect to your aircraft, and also you can make calculations about the velocity closing in between your aircraft and the other aircraft, so you can calculate if you have using the radio frequency, you can calculate if it is possible to have an incoming collision with another aircraft. It will give you a warning using the TICA system, traffic collision advisory system. So you can see also that in the displays, in the primary flight display, in the navigation display. So I will show you all these things. So maybe I have to start with the flight management computer. So I insert all the data of the aircraft for this flight. That includes the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board. The fuel on board that includes the trip fuel, the reserve fuel, and the taxi fuel. The flight management computer is going to calculate where the fuel is stored in the left and the right wing, how much quantity we have, like I think we have 30% in each left and right wing tank and 10% in the center tank. So we'll calculate the center of gravity of the aircraft right now using the mean aerodynamic chord of the forward wings. That is approximately 23% of the forward wings chord line. It's a position with the maximum aerodynamic lift focus for an airliner aircraft and most aircraft. So it's also the position where the stall will begin. We're gonna have the airflow over the top surface of the wings become detached. So we have to pay attention over here. In the primary flight display, the airspeed indicated should be always above the stall speed. So you see the stall speed with red and yellow indication below the airspeed. You can see also the altitude, the target airspeed selected from your autopilot flight director system panel, the target altitude, the pitch ladder in degrees, the bank angle also as we fly, how steep we bank, and also here you can see the rate of climb descent of the aircraft in tens, hundreds, thousand feet per minute, or the trigonometric angles in degrees we can climb descent. The barometric pressure of the outside atmosphere 39.92, the radio altitude minimums. So we need to fix some settings using the flight management computer. Is going to display better. You can see also the pitch ladder degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down. So you have to pay attention when you fly. You might have a positive pitch attitude, but the aircraft might be falling down. You have to pay attention to this needle to make sure whether it's climb descent. Also you can see the steepness of the bank angles and the airspeed. So this is all the air data, the pitot dynamic for the airspeed and the pitot static for the airspeed and the altitude difference and the rate of climb descent. We have the air data computer here. Over here in the overhead panel you can see heading reference and IRS, inertial reference system. Left and right is for the inertial alignment of the aircraft in the GPS coordinates and using the magnetic north pole and the true north pole, magnetic and geographic north pole, magnetic variation. So you have to pay attention to your data computer every time to see all the data of the aircraft displayed correctly. Also the GPS position. So you can see the terrain and weather reflection from the weather radar, the elevation above the field over here in front of you. So we're gonna see later. I'm gonna set up the flight management computer. We're gonna have a better view of all these indications. So maybe we need over here. So you can see here we have also a few more things to note before going to takeoff. Um, I will set up now the flight management computer, a flight one, using all the data. I need the takeoff gross weight. As I told you, the center of gravity is going to be calculated. Then, as we're going to be flying, the aircraft will burn fuel during its flight. It will empty some tanks. Some position will be shifted during using the center of gravity calculation. So it's recalculated every second using the flight management computer. Also, the bank angle the aircraft has in flight, or the angle of attack of the aircraft. You can shift the fuel on board in the fuel tanks, so this affects the center of gravity also, and the drag generated, the lift from the wings. So I will show you a couple of seconds maybe. You can see here I'm gonna talk to you about Newton's physics, aerodynamics, and aerospace engineering. You can see here the wings of the aircraft hold the weight of the aircraft as it flies. You can see the mean aerodynamic chord position is 23% of the Mach, pretty much located here. Is where the maximum aerodynamic lift occurs in the wings. Is also where the stall will begin. In the top surface of the wings, the airflow will become detached. You have the thrust to move the aircraft forward from the jet engines. We have the elevator here for climb descent, the rudder, make turns, aileron spoilers. So we have the airflow deflection. So this is things we need to know using for the air transport pilot license. We need to know aerodynamics and aerospace engineering principles for flying the aircraft. So we can see we have this center of gravity here, pretty much where the mean aerodynamic chord position is. We have the vertical axis, the longitudinal axis transverse through this position all the way back to the horizontal tail. We have the horizontal tail trim. We can trim the horizontal tail up and down, the whole tail plane form like this, up and down. Also we can trim the rudder, the ailerons. So mainly we trim the horizontal tail. Also we use the elevator for climb and descent, as you can see. So we have the longitudinal axis that affects the horizontal tail forces that affect the moment arm through the center of gravity for climb and descent, and also the thrust levers. And also we have the bottom surface of the wings. You can see here, using the Bernoulli fluid, is more flat. So as we accelerate for takeoff, the aircraft is having the airflow is having a lower speed below the wings, which creates higher pressure below the wings, which pressurizes the aircraft weight and wings up into the air. So also you can see the top surface of the wings is more curved, has higher curvature. So using the Bernoulli fluid again, you can see the airflow is moving much faster above the wings, which makes the aircraft wings have higher airspeed of the airflow above the wings. That makes the air pressure lower above the wings to pressurize the aircraft wings below, and depressurize above. That creates an air suction that sucks the aircraft weight up into the air from the top surface. So this is a few things you need to know for the air transport pilot license. So I'll show you a couple more things here. Inside the cockpit you can see we have, so we're gonna set now the flight management computer, the autopilot panel, the thrust levers. So we'll set up now the flight management computer. I will show you maybe the flight controls of the Boeing 787. I control using the side stick, the control wheel, and for ailerons and spoilers, and also the yoke, the control column for the elevator for climb descent. So we can use the horizontal tail elevator for climb descent. I use the side stick. Also I make bangles. I use the ailerons and the spoilers, the control wheel, also the rudder pedals. I have the vertical tail of the aircraft, the rudder, to make yawing turns left and right. And also for nose wheel steering, the ground is interconnected with the tiller and the nose wheel steering. from like 76 degrees deflection left and right of the nose wheel to like 40, then maybe 7 degrees or 0, like in a speed of above 40 knots to 70 knots in takeoff. And then we have only the rudder that becomes aerodynamically effective from 45 knots in takeoff for steering. And then we have also, so you can see I'm using this side stick called Extreme 3D to control the elevator up and down for climb here and descent. As you can see, make turns left and right, ailerons and spoilers. So we have also, I have in the side stick the thrust levers, I have the flaps in this flags. We'll show you how to use them. They're secondary flight control, the speed brakes, the horizontal trim stabilizer also. We need to trim the horizontal tail of the aircraft during the flight, as I told you. So you can see we have the horizontal, we have the thrust levers here. Move forward, enough position. So we have also the horizontal trim stabilizer here, which affects the horizontal tail position. You can trim down, trim up this way, trim down this way. We have, as you can see, so this is the elevator trim, as you can see. We have the autopilot disconnect. So this is the autopilot disconnect. This is the elevator trim, and this is the head-up display declutter. You can see we have 3 switches. We use for the horizontal trimming this one. So you can balance the aircraft using the horizontal tail, trim up and trim down. You'll see how many degrees you trim up and down over here, nose down and nose up. So we'll have the demoted after we're gonna set the flight management computer. Also we have here the pitch trim alternate, pitch down, you can see, pitch down the nose of the aircraft, and also pitch up the nose of the aircraft this way, the other way. So you can see elevator, nose up. We have also the parking brakes set here. We have also this stabilizer trim cutoff switch. So this is a guarded switch. You can see from normal, if we have a failure of the L2 and R2 hydraulic system or either one, we can open here and disconnect. We're gonna lose the auto trim function and we disconnect both from the autopilot flight director system panel, since this is a fly-by-wire aircraft. So this is for all the Boeing aircrafts, Boeing 737, 747, 757, 767, 777, and 787. You need to open and disconnect if you have a failure of the L2 and R2 hydraulic system. Over here, if you disconnect both, then you're gonna lose the auto trim. Use the manual or alternate manual trim over here. Pitch trim position, you can see the pitch trim. Also the outside view, we have the horizontal tail plane over here for climb and descent, and also horizontal trim stabilizer position. So this is the trim stabilizer over here. This switch, I have it here mapped. I have the position of the flaps also over here. We can see how many degrees retract or extend over here, like 5, 1 degree, 0 is fully retracted. Then we have 15, 20, 25, 30 degrees over here, fully extended flaps. So we have also the speed brakes here. Speed brakes retract and extend. We have the fuel control also to the left and the right engine, fuel control, run and cut off. Also later we have the left and right engine thrust levers, the engine thrust, the auto throttle disconnect here. You can disconnect the auto throttle, takeoff, go around, thrust reverse. So we have all this. We have also fire extinguisher for the left and right engine, transporter, radio communication panel, rudder trim. So I will show you all the controls. Also you can see landing gear here, extend and retract, alternate gear. You can see the displays here, down and or up, parking brakes over here set, ejector takeoff. You can see the auto brake, RTO is the auto brake here, position right now, RTO ejector takeoff. So we disarm, auto brake. So these are a few of the indications, and I will show you the flight controls now. As I told you, the elevator for climb and descent, bank ropes, left and right turns, the rudder pedals. So we use the elevator for climb and descent to use the horizontal tail elevator for climb and descent, deflecting the elevator of the horizontal tail up and down. Bank ropes using the aileron, the spoilers and the flaperons, and the rudder pedals using the rudder, the vertical tail. Make your own turns left and right, rudder pedals. So you can see here the display. So we can climb, descend like this, make turns to the left, make turns to the right as you fly, rudder pedals, nose wheel steering. Also we have interconnected from the tiller, the nose wheel steering. So climb, descend, make turns to the right, make turns to the left, flaps and slots, speed brakes and thrust levers here. You see the thrust levers move forward or up. Horizontal trim stabilizer, as I told you, in the thrust levers position. We'll explain later what it means here in the indications. You see I'm moving the thrust levers forward enough since the thrust command by the engine. So this is how to use the flight controls in flight. What we have also, I will show you also that view of the flight controls system, the side stick again. So you can see another view. Also you also the outside view of the flight controls, how you use the side stick or the yoke, depending what you fly, Airbus or Boeing. So I have for this simulation the side stick to control the Boeing yoke for climb and descent. So it's pretty much the same thing. There is no difference. You control the same flight controls, a fly-by-wire aircraft. So you give a fly-by-wire electric command to flight control surfaces, and so it creates a hydraulic pressure in the hydraulic controls. So I will show you also that. So you can see again, using another view over here, we can climb, we can descend. So this is how you use the flight controls over here of the Boeing 787. Climb and descent, leave neutral, make turns to the left, make turns to the right. So you see both the captain and the first officer are interconnected and move together in flight. They're not moving separately with the side stick priority like the Airbus, unless you have a failure. So we have also the side stick deflection is proportional to the yoke deflection, also the thrust levers and the horizontal trim stabilizer here. Very important. So also the outside view. You can see we can climb like this using the horizontal tail. So use this deflection, you climb. Using this, you descend. can see all flight controls, the tail. So you can see also ailerons and spoilers control with the spoilers extended, also with the spoilers retracted. So this is for the flight controls lesson right now. Hope you like it. So you can see also the horizontal trim stabilizer. As I told you, the horizontal tail of the aircraft, very important, trim the way it should be. So I will show you now the rest of the systems of the Boeing 787-900 aircraft. Then I'm gonna show you the autopilot flight director system panel, the flight management computer. I will set up a flight right now. The thrust levers, the indications of the engines. Then we're gonna make an engine start demonstration. I will show you the overhead panel. This section over here of these systems, electric, hydraulic, fuel system, and electronic engine control for the engines with the auto start, pressurizer and bleeder from the engines for ventilation, for air conditioning, for other systems also. So the electric, also the APU, we're gonna start the engines, the batteries, the contactors from the engine. And this is also you also now the flight management computer. I will create a flight run using the flight management computer. I will put all the data of the aircraft for this flight. As I told you, takeoff, goes weight. I will select also here control quadrant. So I'll come here. So I set the initialize. We have over here the index. We can select either what we need, position, identity. That's the Boeing 787-900, the position, reference airport, Lszh. This gives us the GPS coordinates. We can also align if we need. The route, we're gonna select the route from this Lszh Zurich International Airport back to Zurich International Airport. Copy paste. Clearing this, and then we have runway 14. So this will give us a selection. You will see in the navigation display later. Initialize route departure. We'll select the departures, the seats, the southern instrument departures here. We're gonna select the horizontal or vertical navigation fixes for the initial climb, and the runway we're gonna use of the Zurich International Airport in Switzerland. So we'll select runway 14 and Trans Zui for the initial the seats, initial climb. And we have the cruise to the cruise level. We're gonna select ILS, localize the arrivals. Over here the approaches, select an approach, so it's gonna be ILS 14. It's gonna be Trans Amity, and we're gonna use this star, the Negria 1 Alpha, which is the southern terminal arrival. Waypoints and fixes. So this is the approaches. As you can see, you can change either one. So we have the legs now created from the flight plan, but not yet activated. We need to insert a few things. So we have over here cancel the discontinuity. We're gonna select here initialize. Over here we have the zero fuel weight plus fuel on board gross weight for takeoff. As I told you, we're gonna select the cruising altitude 25,300 feet, the reserves fuel 5%, the cost index 100%. Over here the fuel freezing temperature, cruising center of gravity, so it's gonna calculate the center of gravity to 88%, and also the fuel freezing temperature. So we need to recirculate the fuel. This is done automatically, so we execute that. This confirms that the flight plan is ready. We have the first, second, third, fourth leg with the waypoints crossing, and then climb 20, flight level 22,000, Mativ, then begin the descent over here after that. Mativ Amiki Zui Trans ZH 710. You'll see them displayed in the primary flight display TRA C114 Osnem, runway 14, approach and elevation. So we have initialize again, use flaps of 15 degrees for this takeoff, thrust and center of gravity automatically, calculate center of gravity over here, 23% of the mean aerodynamic core position with these flaps. This runway 14 is gonna give us all the information we need, all the data, takeoff speeds, V1, V rotate, V2 over here. So we have a few more things that we need to see. VNAV alternate, VNAV progress, FMC communications hold, we can hold in flight, select a point to hold, the fix, navigation radio. So this is all the things we need to do and know. The legs again. So we're gonna see we created a flight plan over here in the flight management computer. This is what we're gonna use for navigation of the aircraft. So we can connect the autopilot flight director system panel. We will receive the VNAV navigation functions from the flight management computer data. So I'm gonna show you also that. So I'm gonna show you now the flight plan created in the primary flight display. So I use, as I told you, to take off rush weight of the aircraft. I will make the explanation of the system. So we have over here, you can see the flight plan we created. You can see the terrain with red, green and yellow indications, the blue also of the sea, later as we're gonna be flying. The airports with the blue indication for letter name. You can see the waypoints we have to cross through over here as we're gonna be flying and take off, also in the HSI from this runway, take off, climb, cruise, descent, approach and landing. So you can see also the terrain in front of you. We have some mountains you see with the yellow, the vertical elevation of the aircraft as we're gonna be flying. You can see the slope also we have to climb. So you see the terrain in front of you, sideways. So we have also the plan. So for indication, you will see also here we have the runway. If we look closer, the runway we're gonna use for takeoff, the taxiway in front of us, the aircraft symbol, and the runway on the other side. So you can see here the runways and the taxiway. Then if we look outside, you can see here in the navigation display the flight plan, the GPS position that we have in the runways, same way as the GPS is telling us. So we're gonna use also a few more things to see here in the primary flight display and the navigation display. As I told you, we're gonna change some settings from the autopilot flight director system panel. So this is the navigation flight plan of the aircraft created. You can change some indications here. You can see we have to cross through these waypoints. We have also the climb here. We have to climb through some waypoints. So we change the range. You're gonna see a little bit further away. Then you're gonna see how we climb and then how we begin the descent over here. This is the vertical, how far we're gonna climb above the air with the purple magenta line, as you like it. Also the center display. Also we have the plan here created, so you can see the plan. Also how far we're gonna climb from here, cruise through here, descent, start the descent, approach and landing. So this is the plan indication. Map centering. So you can look further away, you'll see more airports. Looking closer, you will see the aircraft where it is positioned, the runway we use for takeoff and for landing. So I'm gonna show you a couple more things. So we need to know the thrust levers, the indications of the engines. So I use the takeoff gross weight as I told you, that includes the passenger, cargo and the fuel on board. The flight management computer calculates the mean aerodynamic core position, the center of gravity. It's gonna calculate also, we use the flaps setting 15 degrees for takeoff for this runway. This is the national airport, runway 14, but we're gonna use the runway 14 of the Lszh airport, both for takeoff and for landing. So we're gonna use flaps 15 degrees, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, the temperature of the air, also the runway conditions, if it is ice, dry, wet. The flight management computer is going to calculate the takeoff speed V1, V0, and V2, just I'll show you. I select the seats, the southern instrument departure, waypoints and fixes, that include horizontal and vertical navigation fixes for initial climb of the aircraft, the climb to the cruise level like 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're going to cruise either one. Then we have we're going to begin the descent and approach. The total of descent back to the airport elevation. We have the SARS, the southern terminal arrival waypoints and fixes for the terminal arrival and approach of the aircraft. So we're gonna have to align the aircraft with these waypoints, the stars. You're gonna see also we're gonna tune the ILS localizer of the runway 14 of Lszh International Airport in Switzerland again. For alignment and navigation to the runway, I'm going to use the horizontal localizer and vertical glide slope as I told you from the radio frequency transmitted from the runway. We're going to have to use the magnetic North Pole heading for alignment with the ILS localizer. So I will show you how to use the ILS localizer for approach and landing. We're going to have the flaps again 30 degrees for approach and landing, the airspeed like 160, 170 knots, and a pitch altitude like 9 degrees. The landing gear extended, so we're gonna be approach and landing. You're gonna see the whole flight from takeoff, climb, cruise, descent, approach and landing. Full manual. I'm gonna show you how to use all the systems. So we're gonna have a complete route of flight path of flight plan. It's gonna be used also from the autopilot flight director system panel over here. Using the LNAV with the VNAV navigation, you can see. So we have the thrust levers. You can see I move the thrust levers forward and aft as I told you. So we have the thrust levers over here. You can see it will display something over here. In the ACAS and indication control system display, you can see the M1, which is the low speed standard stuff, low pressure compressor and turbine of the turbofan boots engine, the left and the right. You can see some indications here, I will show later. So we have the takeoff limit 100.4% takeoff, total air temperature, some occasions and warnings here. The exhaust gas temperature per engine left and right, the M2 which is the high speed source of high pressure compressor and turbine of the turbofan which is engine left and right, fuel flow per inch per hour 1000 kg 1000 pounds, oil pressure, oil temperature, oil quantity and the vibration of the M2 stage of the engines. So we have the GNX. Turbofan turbojet engines installed in our Boeing 787 jet aircraft, one left wing, one right wing. 4 symmetrical thrust and retarded seats, one produces a lot of thrust and contains a gearbox with the farex The FAREX are the full authority diesel electronic control computers. One is for parency gearbox, float sound and redundancy. When sound fails, the other takes over, controls most of the displays of the NZ data. Using the upper and lower ACAS, like the N1, which is the low speed starter, low pressure compressor, a turbine over the turbo fan, which is engine, the exhaust gas temperature per engine, the N2, which is the high speed starter, the high pressure compressor, a turbine over the turbo fan, which is engine, the fuel flow burns per 1000 kilograms or thousands of pounds, oil pressure, oil temperature, quantity, and the vibration of the N2 stage of the engine. The FAREX also control the outflow valves of the 5th and 9th stage and the bypasser from the front fan engine. We need bypasser and outflow valve from the high pressure compressor. For cabin pressurization, wing and engine the ice air conditioning and ventilation, and cabin pressurization. For hydraulic fluid tanks, also as I told you, pressurization, so we can see. I'll show you here a couple of things. So we have the outflow valves pressurizer. You can see this is the cabin pressurization set to the manual right now. So very quickly I will show you the display here. It displays the indications, cabin altitude, the warnings, because we have outflow valve in the manual now, and the cabin altitude needs to be in the auto. So we have cabin altitude set. When we climb to 40,000 feet, it's gonna be maximum of 8,000 feet. So we have a differential pressure 7.8 or 8 psi. Landing altitude, the rate of climb descent, forward and aft outflow valves. Position, we have some other indications here also. Gross weight for takeoff, total fuel on board, fuel temperature. We need to hit the fuel also, rudder trim, flaps position, standby display. So also here all these systems. Just before we're gonna make an engine start demonstration. So the FAREX control also the outflow valves for higher or lower. If we have an overpressure and under pressure in the engine, we can open the outflow valves in higher or lower position to relieve the pressure inside the engine or increase it. We have also the outflow air from the 5th and 9th stage is used for hydraulic fluid tanks pressurization. We can engine at the ice air conditioning, ventilation, cabin pressurization, oxygen regulation, the cabin, the cockpit. So we need for the hydraulic fluids. When we move the flight controls, we have electric flight control system, the fly-by-wire, that commands electrically the position of the flight controls. But you see the yoke, the control column, the control wheel, the rudder pedals all need hydraulic fluid pressurized air, hydraulic fluid pressurized liquids, and this is pressurized with air from the engines. Outflow valves when the engines are working, or we have the APU on. You can turn on the APU also as a backup, or the rammer turbine. So flight controls, nose wheel steering, landing gear, extender, retract, thrust reversers for the engine, flaps, slats, speed brakes, parking brakes, and normal braking. All need hydraulic fluid from the engines to move around, like you see in the wings, the rudder, for making turns and balancing the aircraft in flight. So we need also pressurizer from the APU. We're going to show you later how to start the engines. It's going to supply, we have a smaller turbine in the tail of the aircraft. We're going to use it to turn on the engines in a cold dark aircraft. So we have also the FAREX control, as I told you. The fuel heat exchange sensors, the oil heat exchange sensors. They can, if we are in flight in a high altitude, the fuel is going to be freezing, like in minus 37 degrees or lower, so we need to recirculate the fuel all the time from the wing tanks and the center tank into the engines, left and right wing engine. So it's recirculated automatically using the FAREX, so it's gonna be avoid freezing. It's gonna duct heat from the engine's component and also cool down the engines. We do the same for the oil and lubricant. So we have also the FAREX control the fuel flow to the engine, fuel metering unit, engine start, engine shutdown, engine failures. As we climb the aircraft also from the sea level or the ground level all the way up to like 20, 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea level. or the elevation of the airport is gonna be flying higher and higher. The pressure of the air, the density of the air, the oxygen level become less than half than that of the sea level. Also, the aircraft is going to be flying with an airstrip rate like 2 or 3 times faster than that of the sea level. Also, the temperature of the air is going to be freezing like minus 30, minus 40, minus 50, minus 60 degrees Celsius below zero. So we're going to have a different fuel mixture request every second because the aircraft is going to be flying faster. We're going to have a higher intake of air from the front fans, so this going to be adjusted automatically. Also using the Forex are controlling automatically the fuel mixture adjustment every second. Also as we descend, vice versa, we're going to be having again a different fuel mix request. So it's a good thing to have the Forex installed into your engines. And also the autopilot flight director system panel, the overhead panel. We're going to make an engine start demonstration. So very quickly we're going to set here the autopilot engage. You can see disengage the auto throttle left and right, engage, disengage the airspeed, DL nav with the VNav navigation, this button, so also here the switches, flight level change, auto throttle, climb continuous, auto throttle left and right, autopilot engage and disengage. So we disengage the autopilot, flight director off. You can see the modes are off. Now we cannot rearm them unless we have the flight director on. We set the airspeed like this for takeoff. We have indicated airspeed or Mach. The bank angle, limit in flight, increasing altitude. So we set also this. The heading selects magnetic north pole heading. I'm gonna set 136 degrees. The altitude we're gonna be flying 35,300. Select thousands, then hundreds. Vertical speed, we can zero, we can descend like this, or we can climb the other way when we reach. So you see all the controls of the autopilot flight director system panel. So you see now the climb over here. We have also the roll localizer and the approach for autoland of the Boeing 787. So we're going to be having the displays now in the autopilot here. On the primary flight display, airspeed select and altitude select. Set also. So this is the last things we have to see. Also the overhead panel, I will show you the systems now. Over here we have electric left and right IGZ, integrated drive generator that produces alternate current, 120 to 200 volts for 100 Hz frequency. The APU in the start position, the battery on. The primary flight control computers in the auto position over here. So you see all the systems, the heading reference, air data computer, primary flight control, FD, towing power, battery. Over here we have passenger oxygen, window sheet, rammer turbine, hydraulic fluid pressure over here. Turn off, left and right engine driving, you'll see what happens, the full display. So we have both left and right off, back to on. We have the electric also, so we leave back to auto. We have the lighting system and the windshield wipers over here of the aircraft. We have the wing and engine anti-ice over here on or auto. The recorders of the flight, the APU and cargo fire system. We have the electronic engine control for the engines here with the auto start position, normal and alternate mode, fuel jettison, we can dump some fuel in flight. We arm this left and right wing fuel tank, center tank, the crossfeed valve. We can use either the crossfeed to feed either engine with other pump, the balance also over here, fuel booster pumps. We can also balance the fuel between the left and right wing. So we have the air conditioning and ventilation, the PAX control from the engines, pressurizer also from the APU, cabin pressurization, outflow valves for climb or descent, and set to auto. We don't need to do anything. So we have only one thing to do. See one more thing over here. One last system, and we go for the engine start demonstration. As you can see, so we have the system displayed here in the digital format. You can see all the systems of the aircraft. We have the hydraulics over here, the APU, the oxygen level, liquid cooling, electric left and right IgG, as I show you in the overhead panel. The APU is running, the load set, how many volts you have from the main battery in the APU battery, 100 volts, 400 Hz frequency, 130,000 kilovolts. The hydraulics, where the hydraulic fluid goes, what system used, the man primary left and right engine driven, electric C1 and C2, the fuel left and right wing fuel tank, 11,000, 11,000, 11,000, total 34,000, low and high pressure fuel valves from the left to the right wing, and the center tank feed both engines. Also the crossfeed valve is off, but we use it, can feed either engine with either pump or either tank. The APU is fed from the left wing using the DC motor. Fuel booster pumps forward and aft, and we have the recirculation of the fuel to the engines. You can see minimum fuel temperature here displayed, minus 37 degrees, gonna freeze the fuel. So we need to recirculate the fuel automatically. The air pressurizer from the parts left and right engine. The doors are closed, the cabin can be pressurized. The gear, you can see the pressure of the tires and temperature of the brakes. Flight controls here. We move the flight controls like this. You can see the deflections are created from the flight controls, so everything is normal. As you can see, the tail also. So we have FS display, maintenance system, circuit breaker system again. So a few more things to see. Checklist, last thing to see before doing the engine start demonstration. Normal menu, what to do before takeoff, after takeoff, landing, navigation display again. So we need to turn off fuel control, both engines off like this. So you see fuel control, both off. You'll see what happens. Both engines off. You see the systems are turning amber color. So we have the warnings that the engines are going off. So we need to restart them very quickly, automatically. We use the auto start over here. It's gonna take like 1 minute. Both auto start to the auto position. We'll see all the amber indications now in the overhead panel. So we're gonna have pressurizer only from the left and the right. From the APU, we're gonna see the N2 increases above 20%. We can let the fuel control on like this. So now we have pressurizer, we can let the fuel flow open. So fuel control both left and right on. I'm gonna have the auto start turning on. So the auto start is on. You can see the engines are kicking in. We have a few more seconds. All the indications are normal. Auto start to the maximum, and we're gonna be having running engines. As you can see, both engines are running right now. So we can go for takeoff, select flaps for takeoff. Over here, speed brakes retracted, so we have the view for takeoff, and we go into the runway. We taxi into the runway like this, advance thrust levers forward. So we taxi now to the runway for takeoff, so stay with me. You're gonna see the complete flight. So this is the runway is empty. We take the runway clearance. from the air traffic control and use the nose wheel steering here. So use nose wheel steering, tiller like this for alignment. So we use takeoff power like this, full takeoff of burn. So we're taking off. So we have 120 V1. We rotate the aircraft slightly. So we have a positive pitch attitude, as you can see, and we climb, positive rate of climb. So landing gear up like this. So we have the positive rate of climb. You can see we are 2,200-400 feet above the ground. The airspeed is 175 knots, the stall speed, but we are 4,300 above the sea. We climb with about 5,100 feet. The pitch attitude right now is over here, almost 23 degrees. So we need to pitch down slightly the aircraft. Maybe flaps a bit higher. So we have also the display here. You can see the navigation display, what it displays. You can see the terrain with the red, green and yellow indications, as I told you. How far above the ground we are flying. Also the indications from the engines. You can see also the head-up display. So it's the thing. Now we have to start turning the aircraft. So you can see we keep climbing over here. So we have a very beautiful view over here, the Switzerland, the lakes. So we're gonna start the turn now for the cruise level. So we begin the turn like this. We keep climbing. So we're leveling off. You can see we can hand fly off the aircraft like this sometimes. Pitch down a little bit more maybe. Climbing 11,000. Also here the indications. You will see both sides flight plan with the magenta or purple line over here. We need to fly through these waypoints, as I told you. You can see the terrain with green. Also the airspeed here, the stall speed, the altitude we are, rate of climb, pitch attitude, like 13 degrees right now. So maybe we need to retract some flaps to increase the airspeed of the aircraft. Better airspeed. You're gonna see the stall speed here increase, reaches our point, the yellow. So we need to avoid the stall speed all the time. We're gonna have better marking for the stall. So this is the cockpit after takeoff, how we fly. Also nice view. Now I'm gonna show you from the outside. So you can see here again the aircraft, the indications. So we have the Germany, my homeland, in front of you, France in this side, the Italy from the other side, the Switzerland here, the lakes. So we have the Germany, Bayern Munich here. Also the galaxy, you can see A beautiful galactic view over here. And we're climbing with the jet aircraft. So we have to make a small turn in a couple of minutes. So we are at 17,000 feet. We need to make the turn. Use more flaps for the turn. So this is how we turn. And we have 12 more minutes to go back to the airport. So we align with the flight plan here, as you can see. Have the autopilot indications, the engines indication, flight management computer here, and the primary flight display. So we're following the flight plan, as you can see, very accurate. So we keep climbing 20,000 feet. Beautiful view. Gonna be having the lakes here, the Switzerland. We are at 21,000 feet. We're gonna be starting. We have the Germany and the France in this way. The lakes. So we're gonna be starting turn back to the airport like in 1 or 2 minutes. So we're gonna be flying closer to the lake. So we are here. So we need to start the turn now over here, and we have about 10 more minutes left to go. You can see we can flying, the aircraft keeps on flying. Use some right rudder for the turn to make it more accurate, like coordinated, you know. So we're gonna be in the flight plan again in a couple of minutes. So this is how we turn over here. 23,300 feet, overflying Germany, France. A beautiful galactic view. So we have a beautiful view here. The Boeing 787. So keep turn over here. Hand flying the aircraft. So this again the cockpit, beautiful cockpit here. (34,300 feet). Keep climbing. And we're gonna start the descent in like a couple of minutes. So we're gonna cross through here. Climb a little bit higher, we're gonna see the frozen vapors. We're gonna reach the stall speed limit also, so we are 36,000 feet. We're gonna be having frozen vapors now created from behind, from the engines. Still not have them. Need to climb a little bit higher. So here they are. We have the frozen vapors over here. So we need to start the descent in a couple of minutes. So this is the frozen vapor from the engines of the Boeing 787. And now the view from over here, beautiful view. We need to start the descent in a couple of minutes. We have the lakes behind us, the Germany, Bayern Munich, the France. So we're gonna start descent. Initiate the descent now. And we have 7 more minutes for the approach and landing. We are overflying the region here in the airport. So we start the descent. We have 6 more minutes left. So we're following the flight plan, as you can see, and also maybe a little bit more thrust, maybe descend faster, rate of descent. $19,000. So we have 5 more minutes. As you can see, we are descending here. We start making the turn in a couple of minutes for the airport. And we have 5 more minutes left for the approach over here and landing. So we're gonna start the turn now. Like this. Apply left rudder, and we have 4 more minutes for the approach and landing. And also decrease the altitude. So we need to align now with the runway heading. As you can see, apply some thrust, a bit more thrust. Also landing gear down. So we're gonna use a little bit more flaps for the approach and landing. And we have 2 more minutes left over here for the approach. So we're gonna be approaching manually. As you can see, gonna be having nice view over here for the touchdown. So we are need to align over here. We have 1 more minute left. Apply a little bit more thrust from the engines. We are also aligned with the Lszh localizer here. As you can see, all the indications are correct. So we have 1 more minute left. We need to use a bit more flaps, full flaps, increase the thrust. And approach, we need to align. We have some side wind, use all flight controls, ailerons, spoilers, rudder pedals. Need a lot of rudder pedal for alignment over here. So we have a few more seconds. Idle thrust now. For the approach and landing, we need to increase the rate of descent and use the flare now. We're gonna be flaring. So we hold like this, beautiful touchdown and landing. So we need to align parking brakes here, a little bit rudder pedals, and idle thrust and reverse thrust. So we're slowing down the aircraft. Slowing down. So you can see we're slowing down here. A little very beautiful landing. All flight controls. You can see the landing gear outside is perfectly normal. There is no breakage, and we made a perfectly nice and normal stop over here. So you can see the landing